Well, welcome. Let's do a little bit of introductions. This is me, Erik Gross. I'm your instructor tonight. I'm a technologist of a lot of years. I've actually been programming computers, I realized, since about 1981. It's been a while. Professionally for probably about 35 years. I'm a U.S. Navy veteran. I was a nuclear reactor operator, an electronics technician in the Navy a while ago. It's also where I first found out that I really enjoy teaching others technology. And I'm also the co-founder of the Tech Academy and love delivering these classes. I'm glad you're here. A couple of basic rules about guidelines on how the class runs. We have an assistant in the class. You'll see Cheska pop in and out from time to time. She monitors the chat, helps answer questions, does housekeeping behind the scenes. I want to point out that parts of this class may be challenging at certain points. You might run into things that are a bit difficult to work with, and that's just because the learning process is, especially in technology, involves actually just working through some of the confusions in code. Although we do try to make this as approachable and understandable as possible, reflecting how we actually run our classes at the Tech Academy. One big caveat on this: make sure you write code exactly as written, as I type it. In a little while here, we're going to be typing code in, right? The reason for this is a misspelled word or a missing symbol, or even something as seemingly unimportant as capitalizing a word that shouldn't be capitalized can result in errors in your code. Okay, and we'll go into why that is and that sort of thing. Also, make sure you're in a distraction-free environment so you can really pay attention to what we're doing. I want you to get as much as possible out of the class. If you do fall behind, like when we get to the writing code part, if you do fall behind, don't worry about it. Still stay, listen, and learn. You'll still learn a lot. Ideally, you'll be able to keep up, but if you don't worry about it. You'll still learn a lot. Sometimes we get asked about whether these classes are recorded. They are, and we put them on our free YouTube channel within usually the day. They're on the next day. We'll give you links for all that at the end, right? Including links to future events, free videos, other resources, okay? And there's a free gift, so stick around. All right, so I think we've had a couple people arrive since I asked this, so I'll ask right now, if you haven't done so already, please drop into chat. Let me know where you're joining us from. Elizabeth City, North Carolina. Yeah, drop into chat and let me know where you are. I'm in Louisiana right now, where it got really cold. It was 52 degrees this morning when I woke up. It's so nice not to be in the cold weather of Oregon anymore. All right. So, basic agenda. We'll have a short explanation of the Tech Academy. Then we'll get into our actual workshop where we write code. I'll try to answer questions while I'm writing code, but there'll be a brief Q&A session at the end to pick up anything that I didn't catch. We'll go over some information about our boot camps, who we are, how we work. There's a free gift, like I said, and the whole class should take about an hour to an hour and a half. All right, so who are we? We're the Tech Academy. We deliver coding boot camps. If you're not familiar with a coding boot camp, and every once in a while there's someone who doesn't really quite know what a coding boot camp is, and that's totally fine. They're intensive technology training programs. They're designed to prepare people for entry-level tech positions, right? They first came about 12 years ago, right? The very first one in the Bay Area. Boot camps typically last 3 to 6 months. They focus on practical, modern skills. At the Tech Academy, we've been offering thorough, budget-friendly, flexible, and trusted coding boot camps for over a decade. We're coming up on our 11th year right now, which is really cool. Our certification programs are cost-effective. They're self-paced, they're fully online, and they're tailored for beginners, people with no prior technical or coding knowledge. They cover in-demand skills that the tech industry wants and needs. They're endorsed by stellar online reviews. They're really flexible. They can fit around your personal schedule, and they're built to prepare you for your tech career with a really well-rounded toolkit. Nationally, in America, the average cost of a boot camp is around $13,500 at the current time, right? Ours are well under the national average. In fact, we have boot camps that start as low as $59.80. And I want to wrap this section up with just our mission statement, which is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. That's our mission statement. Our product is you working in tech. All right, so a little bit of background here before we get to coding. First is just some simple definitions. What's a program? It is written instructions that you can enter into a computer that will make it do things. That's what a program is, right? And you write these instructions in what's called a programming language, an organized system of words, phrases, and symbols, and they give you the tool to actually create a program to make the computer do what you want it to. It's different than using a program like, a video game or a word processing program, in that you're in charge and you get to dictate through, the program what's going to happen when someone else uses the computer, which is pretty cool, right? The action of coding is just the action of entering those instructions in to the computer to make it do things. And the written instructions you write, they're called code. Pretty basic instructions. But I want to move on to one final definition here. Sorry, pretty simple definitions. I want to move on to one final definition here, which is Python, because that's the language we're going to be concentrating on. There are hundreds, or really even thousands, of programming languages in use today. Python is arguably the most popular in the world. Python and JavaScript are neck and neck for popularity around the world, right? It's really versatile. It's relatively easy to learn for a new person, but it's also very powerful, and you can build all kinds of different computer programs with it. Video games, websites, apps, all sorts of things can be built with Python. It's very, very powerful. All right, now, before I even jump to the next slide, I want to just check something. Let me know in chat. Say yes if you have never attended one of our free classes before. Give me a yes in chat if you've never attended one of the Tech Academy's free classes. All right, I got a yes, a yes, a yes, a yes. Another yes, a lot of them. Okay, good. All right. So we are absolutely going to be doing coding tonight. And you should learn a lot out of it. But I want to clarify that the material we're going to go over on the next slide is, in my opinion, some of the most important information you'll encounter as you learn to code. So with that in mind, what we're going to cover is the 5 basic elements that are found in any computer program. We're going to start with an element that might seem, relatively like almost foolish. It's an entrance point, the first instruction. Every program has to have a first instruction. But there's 2 ways that this can matter to you as a technologist, as someone working in this industry. The first one has to do with a really mechanical thing. Here's what it is. You might have like a bunch of programs installed on your computer. Most of us do. We have a lot of programs installed on our computer. But have you ever stopped to wonder what happens when you double click on that little icon and the computer program starts? One of the things that happens is inside the actual machine, inside the computer, okay? And here's what it is. Computer programs work with data. I mean, there shouldn't be a shock. The purpose of a computer is to take in data, to process it or work with it in some way, and then to send data on. That's what computers are actually all about. And so programs, they work with a lot of data, right? That data has to be stored somewhere inside the computer so that your program can access it and do things with it. The physical device where that data is stored is called a memory device. It remembers your data, right? If you've ever seen the inside of a computer, memory devices are about 3 or 4 inches long. Those little black sticks, they've got little wire metal stuff all over them. You might have heard them called RAM, right? That's a memory device. And on that device are billions of little teeny physical locations where you can store some data. Why do I bring this up? And what does it have to do with the entrance point to a program? Well, when you start a program running on your computer, the computer reserves some of those memory locations just for your program. And it keeps other programs from being able to access that area so that no other program can come in and mess up the data that your program needs. I'm sure you could see how dangerous it would be if there wasn't some control over which program can access what portion of data. It could scramble the data and your program would not be very, very valuable. So that's a mechanical thing. But I mentioned there's 2 reasons why this entrance point, this first instruction is important. And here's the second one. It has to do with how do you go about understanding how a program works when you weren't the one to write it? And this happens a lot. You join a company as a technology worker. You join a team, and that team might be responsible for a number of programs. And those programs probably have been around for a little while or a long while. And sometimes they can be pretty complex, right? I saw a question about this actually on Reddit the other day. Like, it was asking experienced software developers, how do you go about understanding a new program when you just arrive on a team? And I got to tell you, understanding this principle of the quote unquote first instruction is actually a key tool for you here. When you're faced with a very large, complex program, finding out for that type of program where in the code you'll find the first instruction is really, really important, because you can actually just start looking through all that code, find that first instruction, see what it does, and then go to the next instruction and the next and the next. And that way you're viewing the program the same way the computer does. The computer is going to start at the top of the program, start at the first instruction, and move forward. And it's a really great way to just move through that code and understand what's going on. And it's finding that first instruction is different based on, different types of programs, but you can always find it. And you can even Google, where do I find, the entrance point for this particular type of program? So this is a fundamental element of a program, any program. Let's move on to the second one. It's what's called variables. These are things in your written code, and they are just pieces of data that the program can work with. But more importantly, it's data that can change while the computer program is running. Think of, if you're playing like a video game, you might have a score in the video game. That data is going to change as you play the video game. You need a variable to keep track of that. You might need a variable to keep track of your player name in a video game. You might need variables to keep track of all the equipment that you have in a video game. If you are, operating a computer program that manages a school, you might need variables to keep track of each student and their name. Like, they might change their name a little bit. Maybe you spelled it wrong, whatever, right? These are variables, and they're vital for any computer program. The next of these 5 fundamental elements is what are called control and branching systems. What this means is ways inside a program where you can get the program to make a decision, and based on that decision, the program will then do one of 2 or more possible paths, one of 2 or more possible branches. In other words, it's conditional. If a condition is one way, you're going to do a whole set of steps. But if it's another way, you're going to do a whole different set of steps. This is then an incredibly important, vital part of a program, because we write programs to do things that we could do manually. And in our manual work, in productivity at work or other aspects of life, we have to make decisions. You have to have a way in a program to tell that program to make a decision and then tell it what to do based on that decision. And that's what control and branching is all about. Without control and branching, a program is severely limited in terms of its usefulness to human beings. The fourth element of a computer program is what are called sub-programs. I love these. The basic concept is what it says here. It's a program within a program, but let's get a little more specific. You've got your main program, and it starts at the first instruction and then goes to the next and goes to the next and goes to the next. We're going to build, a program tonight. You'll see this happen. But here's what was happening in the very early days of computer programming, 50, 60, 70 years ago. Programmers were finding that when they were writing up a huge program, that there was very often like a set of the exact same identical steps that they happened to be repeating over and over at various points in the big program. And they went, man, why am I typing this out when it's the same exact thing every time? It's the same, say, 5 steps. Every time it's the same. But even worse, let's say they wanted to make a change later on to how those 5 steps were done. Now they've got to go back in their program and find every single place where they did those 5 identical steps. It added time, it added the possibility of errors, and it made maintaining or changing the program in the future a lot more difficult. So some bright person came up with the idea of a subprogram. They said, wait a minute, if we're repeating, say, these 5 steps, and it's the exact same thing every single time, literally the exact same thing, why don't we take those 5 steps, those 5 instructions, and put them off in a little package we can call a subprogram and give that package a name. And then when we're writing our big program, every time we need those 5 exact things to happen, instead of writing all of them out, we just write one thing. Hey, do that subprogram, and when you're done, pick up where you left off. And that's how subprograms work. And you'll build one of them tonight and kind of see how it works for yourself. But without subprograms, a computer program is very hard to build and maintain. So we consider it a fundamental element of a computer program. And the last fundamental element of any computer programming is an exit point. It's the final instruction. And the reason it's important is we need a way to tell the computer, hey, this program is done. It's over. It's no longer running. There are a number of things that can happen inside the computer when that happens, but one of the more important ones relates to the first thing we talked about here, the thing that happens when you start a program, and that is the computer, when you start a program, remember I talked about this, reserves a certain amount of the storage space in those memory devices, and it's only for that program. Well, now that the program is over and it's not running anymore, your computer can unreserve those memory locations, make them available for other programs if they're needed. And so what you see on the screen here, these 5 fundamental elements of any computer program, it's good just to understand programming, but this is one of the smartest ways to learn a new programming language. And we're going to use that approach tonight. All you would really figure out is, okay, for this given programming language, how do I do these things? How do I build these blocks of a program in this new language I'm trying to learn? The last thing I want to say before we move on from here is that I have not listed these 5 elements of a program in the exact order they happen to go in a program. The truth is, other than number 1, the entrance point, and number 5, the exit point, any of the other parts of it can go in whatever order you need them as you build out your program. I had to list them in some order. All right, let's move on. And by the way, I'm watching the chat. If you have questions at all about what I go over, just let me know. We're about to write some code. We're about to enter some instructions into the computer and make it do stuff, right? We need a place to type those instructions, and we're using an online service to do that. My assistant's going to drop a link into chat right now. There it is. When you click on that link, you'll be taken to an editor to write your code, and it happens to be online. It makes it easy for all of our students to, access it, okay? And it's going to look a little bit like what you see on the right part of this slide. On the right part of this slide, you see a browser, and you see a web page that has 2 different sections. On the left part of that section is where you'll type out your instructions. On the right-hand side is where you'll see any output that your program has. If you tell your program to print something or to display something, that's where it'll appear, is on the right-hand side. So this is going to be your code editor. What I want to handle before we start writing code is this. I would like for you to be able to make it easy to follow along, to see my code that I'm writing and your code side by side. So if you have 2 monitors, that's easy. Just put your Zoom, call on one monitor, and then put your new code editor you opened up on the other monitor. If you've only got one monitor, you'll have to put them side by side on the same monitor. And for a little bit of help on how to do that, if you want to resize your Zoom window and it's not being very cooperative, sometimes you can click on this word that says Zoom meeting, and this little menu opens up. Click on restore, and it will collapse down the size of your Zoom meeting. You can move it around to where you want it to and resize it. Same thing on a browser window, because your code editor is in the browser now. In the top right, you'll see this little symbol sometimes. that looks like a square or two squares. When you click on that, it'll let you resize and move around your browser window. So take a moment and set it up so that the Zoom call, where you're seeing my slide right now, is on the left, and the code editor is on the right. And while you're doing that, I'm going to take a sip of water. All right. So we're about to start our coding, okay? We're going to be building a program. Well, we're going to show you a program called Hangman, and we're going to build out some code that belongs in that program. We're not going to build the entire program. It would take about 3 or 4 hours, and at the end of it, you'd fall asleep and you'd be mad at me. But what we are going to do is, 1, show you how the game works. 2, we're going to teach you the fundamentals of Python and programming using those 5 elements that I just talked about. And we're going to do it as if we're building some significantly important parts of this Hangman game. And then what we'll do after that is show you the full code for the Hangman game, and you'll be able to understand it decently well after you've gone through some of this training. And that way you'll be able to get familiar with Python and familiar with programming. So I'm going to switch to my code editor right here. And what I'm going to do first, don't worry about all this code. This is the code for the full game. You're going to get access to this in a little bit. I'm going to paste all the code in, and I'm going to play the game. So on the right here, it says, let's play Hangman. Okay, so there's the Hangman's pole, and then here's the noose, and I'm going to try to guess a letter. I'm going to go with E. Oh, I got an E. Okay, how about R? Okay, how about S? Nope. Oh, my head is on that. And then a T. Oh, I got a T. Okay. How about an O? Hey, I think I know what this is. Hey, I think I'm right. I got it. Okay, good. So that's the game. It's Hangman. Okay. And again, you'll look at the code in a little bit. Now that you've seen that, I'm going to clear out everything over here in the code editor, and we're going to start to actually write some Python code. So from this point forward, pay close attention to what I type and type it exactly the way I do. When you run your code, if you get errors, in almost every case, it'll be because there's something that is a tiny little bit different than what I wrote. Okay, and since I can't see everyone's screen and debug exactly what's going on, you'll need to look closely to see exactly what I write. All right, so we're going to start with a simple instruction that will just print something to the screen. But from that simple instruction, there's a couple really valuable lessons. So follow along with me on the left-hand side here and type print, P-R-I-N-T, like that. Do not hit space, and then hit an open parentheses. You'll notice that this code editor automatically made the closing parenthesis for you, which is great. It's just a nice feature of the editor. And then give me a double quote. You'll find it to the left of your enter key. You'll have to hit shift. And in here, we're going to type hello, comma, world with an exclamation point. And when you're done with that, just go to this triangle at the top here, which is almost like a play symbol you're used to seeing on videos. Click on that. It'll run your code. And look, out there on the right is the output. Now, it's relatively straightforward instruction, but there's a couple of really valuable lessons here. The first one is this. This word, print, is a built-in instruction in the Python language. The second thing to note is this. Notice how there's no space after the instruction. We immediately have some parentheses. By the way, do all of you notice that when my cursor goes near this opening parentheses, this parentheses over here has a light gray outline around it? Do you see that? There's a reason for this, and this is part of the lesson. What that outline indicates is these two parentheses are matched together. They work together. Here's precisely what they do. Many instructions that you put into a computer are going to need to be given some information in order to actually do their job. This print instruction is no different. It absolutely needs some information to do its job. If its job is to display information on a screen, you have to give it that information. The way we describe this is we are going to pass information into the instruction. And the way this works is anything inside the parentheses is passed to the instruction. That's how you give it the data. So this is some of the terminology and concepts involved. In this case, the information inside the parentheses, I'm highlighting this just for focus, the information has to be text information. One of the things we could spend a fair bit of time discussing, but it would make this class a lot longer, is that while you can say, I did say that the purpose of a computer is to take in data, to work with that data in some manner, and then send data on. And that is very true. The fact is, there's different types of data. There's data that's numeric in nature. There's data that is text in nature. They call it alphanumeric, right? Because it's got both letters and numbers. There's types of data that is collections of information. There's a number of different types of data. And again, that would go way beyond the time we have here, but just bear in mind that there are different kinds of data the computer programs can work with. In this case, with the instruction called print, the type of information that it'll work with is text information, or we call it string information. It is a long string of characters. There's an H character and an E character and an L character and another L character. So there's some fundamentals here. Instructions very often need information to do their job. You pass that information into them, in Python at least, by putting that information into parentheses immediately after the instruction. I'm going to come back to this concept in a little while. Here's the other thing I want to express to you, okay, is one, the computers are stupid. They can't think. They only operate on what they've been told to do ahead of time. Now, how does this matter with what we're looking at on the screen? Well, we're looking at a straightforward instruction in Python called the print instruction. Now, we can look at that instruction and we can think. So we can go, oh, well, clearly, this is a print instruction and everything in the parentheses is going to be printed to the screen. That's a human concept. Let me show you how a computer approaches this. Watch my cursor. I'm going to bring it all the way back to the beginning, and we're going to go slowly through this just to illustrate how a computer works. When you tell the computer, hey, when you click on this button over here, right, and you say, hey, please perform this instruction, here's what the computer does. Literally, the computer starts and looks at the very first character, highlighting it, just so you can put some attention on it, okay? Let me look at the chat here. I see a raised hand. Mark, if you have a question, drop it in the chat. That'll be awesome. So the computer starts at the beginning of this instruction and it reads the first character. And then it looks up two things that it has stored in the computer. It has, one, a list of all of the instructions in Python. There's a few hundred instructions in the Python language. It looks through that list and says, hey, this letter that I have right here, it's P, is that an instruction built into Python? It's not going to find it because that's not a built-in instruction. The second thing it looks to is it's got a list of all the variables that are in your program. Now, we haven't made variables, but a basic concept is you give a variable a name. You might call it age or class size or automobile maker. That's a variable, right? Well, we don't have any variables. We haven't made any. This is the first instruction, right? So literally what happens is you press play, the computer reads this letter P and looks up and realizes, oh, it's not a Python instruction. It's not a variable. Okay, I'm not going to do anything. I'm just going to go to the next character. And then it reads both characters and goes, all right, PR. Mark says, how do you get your Trinket screen? Trinket is this code editor. How do you get your Trinket screen to work on two screens? Mine only shows the main.py. Look at this little slider and see if the slider's been moved too far to the side, or maybe your monitor's too small, okay? The other thing is you may want to use a different browser because sometimes the browser can interfere with how this thing's supposed to operate. Those are the two things I can advise. So to get back to this, the computer is started at the first letter. That's not an instruction or a variable. It goes to now looking at 2 letters. That's not an instruction in Python or a variable. Goes to 3 letters, not an instruction, not a variable, and 4, and then 5. And when it gets to 5, it goes print, and it looks through the instructions that it has for Python. It goes, that's an instruction. And what that instruction says to do is look at the very next character. It should be a parenthesis. And so the computer goes, let's look at the next character. Aha! It's a parenthesis. And now what that instruction called print says is go forward until you find a closed parenthesis. So the computer looks through all these characters. It doesn't care about any of them because they're not a closed parenthesis. And then it gets to this one and it says, I found the closed parenthesis. And now what this instruction called print does says, okay, good. Take all of the information inside the parentheses. Grab all of that information. Take that and display it on the screen. Now, I know that was probably, you might even think, a little nerdy, like one tiny step at a time. But I tell you this to illustrate, again, computers are stupid. They can't think. They can't figure out what a print statement is. They don't really know. They only know patterns. That's all they know is patterns and what's already been built into them in terms of patterns to look for. The pattern they're looking for is there a pattern of the 5 characters, print? And if there is, now they know what to do. Until then, all they know to do is just keep looking until they find a pattern. That's the way a computer works under the hood, okay? And the second thing, again, that I want to focus on is many instructions need information, and you pass that information in by putting it inside parentheses. All right. Now, let's move on and have another instruction. Hit enter at the end of this line. Let's make a variable. Now, let's make a variable kind of related to our Hangman game, okay? Let's say you get a maximum of 10 turns of trying to guess the word, right? So we'll make a variable that keeps track of how many turns has the person taken. That's a pretty cool variable. We better keep track of that. So we'll call our variable turns, Turns. So type in the name of your variable and hit a space. And now hit an equals symbol. It's in the top row by your backspace key. And we're going to say it starts out at 0 because the person hasn't even started playing the game. They're about to make a guess. Good. All right. We have a variable. Now, there's 2 things happening in this instruction, and they're both important to know and to understand how they're different from each other. The first thing that's happening is we're actually creating a variable. When Python sees this series of letters, it knows that it's not a built-in instruction. There's no built-in instruction in Python called turns, okay? So it goes, oh, well, then it must be a variable. All right, I'm making a variable. Now, here's the cool thing. It's what happens underneath the hood inside your computer when you make a variable. What happens is specifically this. The computer finds one of those available memory locations in that memory device, and it says this location is reserved. No one else can use this, and we're going to give that location a name. The name is turns. The word we call this, the word we use for this process is declaring a variable. That's the technical name for it. We have declared a variable, okay? And that means both assigning a name to the variable and then assigning a specific location in a memory device for where to store the information that's inside that variable. So now let's look at the second part of this, the equals and the 0. Until we do this part of the instruction, all we have is a variable. In other words, all we have is a specified location in the memory device with a name on it. There's nothing inside that memory location. We haven't stored any information, any data in there. And so that's what these symbols, the equal and the 0, that's what they do. Specifically, this equal, that is a Python symbol. It's part of the language. And what this symbol says to Python is, to my left, you see the name of a variable. To the right is some piece of data. Put the data inside the variable's memory location. So that's what this symbol is. A little more technical, this symbol is called an operator. Even more technical, it's called an assignment operator, which brings us to the word we use for the second half of this instruction. We are assigning a value to the variable we just declared. So here, we declare a variable. Here, we assign it a value. Two separate things happening on this line of code. And it's that pattern always. On the left, the variable. After the assignment operator, the value of the data to store inside that variable. That pattern you will see over and over and over again in Python code. And now you'll know what's on either side of that symbol. Okay, good. So we made a variable. Now we need to use it. I would like to tell the user how many turns they've taken. That would be a nice thing to do, right? So first, we're going to print print. You do your open and close parentheses. And we're going to print, you have taken this many turns. And do a colon. And do a space, because we want a space before we actually print the number. Now, right now, go ahead and run this. It doesn't actually have the information. And this is where variables come in handy. We know the information. It's right here inside this variable. So go to the end of this last line, go after the final double quote, do a space, and then do the symbol plus, and then a space, and now type it exactly, type out the name of our variable. Well, I didn't actually type it out correctly. What did I do here? Oh, there we go. So it looks like that. Now run it, and then I'll explain what's going on. What did I do wrong? Oh, I did this every single time. Okay, good. I like this. It's a chance for me to explain a little something here, okay? So what would you have expected to happen? Well, I know what you'd expect because I kind of implied it. You'd expect for it to say 0, like you have taken this many turns, 0. Now, why didn't it? The clue is in the final lines right here. And I want to explain a word. And it'll open up the understanding of why we have a problem in our code. The word is concatenate. Does anyone in the class know what concatenate is? And if so, drop an explanation into chat. Nick says to join. He's right. It means to join together. That's what concatenate means. To be a little more precise, it means to join together two pieces of data that are both strings. Remember, strings are just alphanumeric characters. We have a string right here. This is a string. We also have a string right here. This symbol means concatenate. It means take the string to the left of me and the string to the right of me and put them together. Like if we had first name and then a plus and then a last name, you would have Erik Gross. They'd be put together all as one thing. Okay, that's what concatenate means. So now let's look at this error. It says you can only concatenate a string to a string, not an integer. No, it's not an int. Int is another type of data. Integer numbers. Can someone say in chat, what is an integer? This just goes back to fundamental math from junior high or high school. What's an integer? Perfect, Nick. It's a whole number, no decimals. So it's like 1, 2, 3, 4, 5, but it's not 1.7. There's no fractions allowed. It's just a whole number. So it could be 10, it could be minus 1,000, it could be 1,000,002, but it's not going to be 7.8. That's what an integer is. The problem is this. We made a variable called turns, and we put some data in it, but the data we put in it is integer data. So this little operator right here says, you want me to concatenate. All right, I'll do my best. So you're supposed to give me string information on the left. Well, you did. Look at that. That's a string. And you're supposed to give me string information on the right. Well, you didn't. You gave me an integer. I can't do my job. Now, part of the reason I really like to show you this error is this. We know what we meant, and we can figure it out just by reading the code. We're like, no, I meant to display the 0. Computers are stupid. They only do what they've been told to ahead of time. And this instruction, this plus, has only been told, hey, you're going to be given 2 pieces of data. One string and another string, put them together. That's how that instruction works. It doesn't know how to figure out what you really meant when you gave it an integer. It can't figure it out. Okay? So what do we need to do? Well, we need to take the data inside this variable, which is the integer 0, and we need to turn it into a string. That's what we need to do. We need to turn it into a string. Well, luckily, Python gives us a nice, convenient way to do that. All you do is you type, and type this along, follow with me, str, and now this part's important. Put parentheses around the variable, one at the beginning, and then one at the end. You might have to type it twice because this code editor will interfere with what you're doing. So make sure you type exactly what I typed. Let's run it, and I'll teach you a little bit more about it. You should get what I got. You've taken this many turns, 0. Now, notice that this str is followed immediately by a parenthesis. Look at which parenthesis has a little gray outline on it, which is the matching. They call it a matching parenthesis. They match, they work together. Just like with our print instruction, which needed to be given some text information in order to do its job, this instruction needs to be given information to do its job, and the information it needs a number, and it'll take that number and turn it into a string. And that's what it does. It turns it into a string. And now, because it's been turned into a string, this concatenate can do its job. It goes, oh, I now have a string on the left, and this is now a string on the right, so I can finally do my job. I can put them together, and it does that right here. So you can start to see some patterns here, I hope. One of the patterns is if an instruction in a computer needs to be given some information, we call that passing in the information. The information you pass in goes inside of parentheses. And the other thing is that the computer cares about what kind of data it's working with. You don't want to tell a computer what is 5 plus Wednesday. Those are two different types of data. And your computer knows how to work with 5, that's number data. I do math with this. And it knows how to work with the word Wednesday. Oh, that's text data. I do like text work with this. But it doesn't know how to do 5 and add it to Wednesday. That doesn't make sense to you or me, and it's not going to make sense to a computer. The computer is not programmed on what to do. A computer can only do what it's told to ahead of time. All right, good. All right. I'm watching chat. If you have questions at all, drop them into chat. I welcome them. Now, let's go to our first thing here, okay? Let's say someone has taken another turn. Let's go change the value of our variable. Type in your variable, TURNS, and we'll assign it another value. Let's say it's 1. Now, do not run the code. Don't run the code. I'd like you to guess in chat what's going to be displayed over on the right-hand side when we run this code. Type into the chat, what do you think the computer is going to display? Ruben, you got that right. Mark, you got that right. Yep. Raven, that's not right, and I'll show you why. It's a really important lesson, okay? All right, so let's run it. And it still says you've taken this many turns, 0. Why? We said turns equals 1 now. Well, guess what? When we ran this instruction to print how many turns, what was the value of the turns variable at that point in time? The computer has not gotten to this instruction down on line 4. It's only gotten to the instruction on line 1, and then line 2, and then line 3. And at the time we are performing this instruction on line 3, the value of turns is still 0. Does that make sense, Raven? Awesome, awesome, awesome. Well, let's do it again, though. Copy this entire line of the print, copy it, and then paste it down below, and now run your code. Huh, okay, good. Now, there's the value of a variable. We can keep track of data that changes, and we can use it throughout our program. Yes, this is a relatively simple example I came up with, but I just want to show you variables are meant to keep track of data that can change. Clearly, in a game like this, you're going to have to keep track of how many turns a person has taken. Speaking of that, let's move on to one of the next of the 5 basic elements of a computer program, which is control and branching. Remember, we're going to have a mechanism that can make a decision, and based on that decision, the computer is going to do one of 2 or more possible courses of action. We call those courses of action branches. In this case, we're going to check whether or not the person's number of turns is greater than 10. Why? Because they're only allowed 10 turns. I'm sorry, that's the way the game goes. You're only allowed 10 guesses, and if you go past that, you lose. So we need a way to control that. Simply put, we need a way to check and say, if the number of turns is 10 or less, then all right, you don't lose. You can keep playing. If the number of turns becomes greater than 10, then you lose, the game's over. We need to be able to make that decision. Guess what? We're going to do different things based on whether that's true or not. So let's show how to build that. You do that, go to the very end here, and start on a new line. We do that with a control instruction. It's a very common one. It's if. So just type if. And then give yourself an open and close parentheses. Now I'm going to type out everything that goes in here, and then we'll talk about each part of it. Turns equals sorry, greater than symbol, you'll find it just to the left of your shift key, and then 10. And then go to the end, the very end, and type a colon. Now let's talk about what's going on here. Remember how I said that many instructions need to be given information in order to do their job. We pass them in some information, right? With the print instruction, we pass it in some text information. With this string instruction, we pass it in a number and it turns it into a string. Well, this if instruction, which is a control instruction, it needs to be given information too. And what it needs to be given specifically is what's called an expression. An expression is something that can be looked at by the computer and determined whether or not it's true or false. That's what an expression is. So this is an expression. The computer can actually look at this and figure out whether it's true or false. Specifically, it all hinges on this little symbol right here, this greater than symbol. This is another operator in the Python language. It's an instruction to the language to say, listen, you have two pieces of data, one on the left of me and one on the right of me. Compare those two pieces of data. And if one on the left is greater than one on the right, then the answer to this expression is true. Otherwise, it's false. That's how that symbol works, okay? So, this if is the control instruction. This is the expression that will be evaluated to figure out whether it's true or false. You can also call it a condition. Is a condition true or false? Okay? But it's this little colon that is really cool. Understanding how to use this colon is one of the pivotal things when you're starting to learn Python. And here's how it works. The colon says to the computer, underneath this current instruction, you're going to find some further instructions. And if those instructions below here are indented by a couple of spaces, you treat them differently. That's what the colon says. Under here, indented instructions are treated differently. Now, I'll explain what I mean by differently in a moment. Okay? The first thing you want to do is go to the very end of the line here, this instruction, and hit enter. And notice our code editor has actually automatically indented or moved over 2 spaces. That's just a friendly thing to do. Some code editors don't do that. You'd have to hit space, space. But that's all it is. It's 2 spaces. The important thing is the instruction that we're about to write is treated differently by the program. Now, I said I'd be more precise, and here's what I mean precisely. The instruction we're about to write will only be performed if the expression right here actually ends up being true. The instruction we're about to write is separate. It may or may not actually be performed. And how do we determine whether or not it's performed? Well, the computer evaluates this expression. So what do we want to do if turns is actually greater than 10? Well, there's a lot of logic you'll see in the real program, but to keep it simple, we're just going to print, sorry, you lose. Or well, actually, we're going to print game over. So print, your parentheses, and then some double quotes, and just type game over. That's it. Go to the end and hit enter again. We're going to print something else too. We're going to say print. I'm going to print play again, question mark. That's what, I mean, yes, like I said, in the real game that you're going to see the code to in a little while, you'd have maybe a little more complex things that happen. But that's essentially what we're going to do, right? If they go past 10 turns, we're like, sorry, game over. You want to play again? That's what we're going to do. And we are only, again, we're only going to do that if the condition up here is met. And the way we clarify, hey, computer, only do these things if the condition is met, the way we clarify that is we put a colon at the end of the control line, and then we indent. Look at those two spaces. We indent the instructions that we only want to have happen if the condition is true. So let's run this. And notice it doesn't say game over, play again. Why? Because at the time that we run this if, this control instruction, the value of turns is still only 1. Well, let's be wild. Go up here to line 4 and make it equal to 16. And now run the code. And now it says game over, play again. This is a central aspect of computer programming. Creating paths or branches that will only be performed if specific conditions are true. It's the way you make a program that can decide things, that can make decisions, that can process things one way in a certain situation and another way in another situation. It's a vital part of your tool box as a programmer. All right, so we're only halfway done here, though. We haven't clarified what do we do if the number of turns is not greater than 10. Let's build that. Go to the very last instruction, the end of the line. This part's super important. Hit enter. And do not start typing where the cursor is right now. If you start putting in instructions in right now, remember, you're still putting an instruction in the area that's only going to be performed if, in fact, this expression is true. That's not what we want to do anymore. Let's just say that with these two instructions, we're done describing what to do if the number of turns is greater than 10. Now we want to clarify what to do if the number of turns is not greater than 10. So on this final line, you have to hit backspace and go back to the beginning of the line. Now we're about to put some instructions that are going to be performed no matter what. They're not conditional. They're not indented immediately following a colon. Look, it's not indented. What instruction do we want to put here? Well, we want an instruction that basically says, all right, give me the alternative. We know what to do if this is true. What do we do otherwise? The instruction is called else. Oh, well, don't capitalize it, Eric. Like that. That's the instruction. But when you put a colon at the end of it, do that, and hit enter. Look, we indented. Now we're going to put the instructions that we want to have happen only when this expression is false. We're going to put the instructions that we want to have happen only if the number of turns is not greater than 10. Again, the code inside the actual program will be a little more complex, but let's just keep it simple for illustration purposes. What do we want to do? We want to tell them keep playing. So print keep playing. That's it. Now, when you do this, make sure you type it exactly the way I do. Make sure that this line is indented. Make sure you didn't forget the colon. And when we run this, well, it still says game over, play again. Why? Because at the time we run line 6, the value of turns is still 16. Let's make it go back to 1 and run your code. Now it says keep playing. We are successfully controlling the path of our program. We're controlling its execution. We're controlling what it does. We're making it make a decision. That's control and branching. Any questions about that? Drop them in the chat. All right. So now let's talk about sub-programs. Go and hit enter. Make sure you back up so we're at the beginning again. And hit enter again just for readability. The blank space that's on my line 11 doesn't do anything as far as the program is concerned. I just put it there so that when we start typing again, there's a little bit of a break to make the code easier to read, okay? I'll tell you what, I don't particularly want, if I'm building this program, to type out this section of code over and over again for every single time someone takes a turn. They take a turn. Okay, I better have this code again. Is the turn greater than 10? They took another turn. All right, I better type out this code again. That's really not going to be a lot of fun to build that program. In other words, we've identified a perfect situation for a subprogram. It's a subprogram that we can call upon every time someone takes a turn. They're done taking the turn. They made a guess. And we can check very easily, hey, are they done? Have they exceeded the maximum number of turns? Let's build a subprogram that does that. So in Python, the way you make a subprogram starts with a Python instruction called def. Type that in and hit space. Def stands for define. Now, what are we going to define? Well, I keep using this word subprogram. This concept of a set of instructions that are a named set of instructions that can be called upon whenever you want them, right? It's called by various names in various different programming languages. In some languages, it's actually called a subprogram. Sometimes it's called a subroutine. Sometimes it's called a function, a method. There's lots of terms used to describe the same basic concept. In Python, we call them functions. So we're about to define a function. And like I said, the way you start is you type the instruction, the Python instruction, def, you hit a space, and now you type the name for the instructions. You haven't put down the instructions yet at all. But you start by giving it a name. We're going to call it game underscore over. Make sure you have the underscore. It's a little bit to the left of your backspace, and you have to hit shift to get to it. Game over. That's the name of it, okay? Notice I didn't hit space. And the reason why is this. Remember, when I talked about this a few times, that some instructions like print or str, they need to be given information in order to do their job. The same is true of these functions. Whenever you build a function, you may or may not need to give it some information in order to do its job. And so what Python requires is, after you've decided on the name of your function, you have to have an open and close parentheses right after it. I did that wrong. There we go. So go to the end and hit your open and close parentheses. What goes inside these parentheses is the name of the information that's going to be given to this function. You can give it whatever name you want, but you choose the name. I'm going to choose the name num underscore turns. Number of turns. That's the name I'm choosing. Type that out exactly. There's another word for the information inside these parentheses. This is called an argument. When you're creating a function, you can also clarify what information is given to it. And you can call that information the arguments for the function. It's a word we inherited from the mathematics world, okay? But they call it an argument. In fact, go up above here. Everybody go to line 11. Hit enter once. And I want you to do a pound symbol. It's above the 3. And then type, we are making a function. It takes an argument of num underscore turns. This symbol right here is a Python symbol, the hashtag or whatever. That symbol is a comment symbol. It means that everything following this symbol on the line is just a comment. It's not an instruction. The computer is not meant to do anything with it. The computer ignores it. It's there for us, for human beings. But now let's go back here. We're partway there. We've used the DEF or define instruction to tell Python, hey, we're about to make a function. We've chosen a name for our function. It's game over. We've decided on an argument for the function, what we're going to call the information that we give to this function. And now we're finally about ready to say, what does this function even do? How does it work? What are the instructions inside it? So you go to the very end, and guess what? You hit a colon. Now, this should immediately tell you that the next instructions, if they are indented, are treated differently. So hit enter. Notice our code editor indents for us in a nice, friendly manner. And yes, absolutely, the instructions we're about to type are different. More precisely, and this is really critical. Pay close attention to this part. The instructions we're about to enter, if they are indented, are inside the function, and they only get performed if and when we actually request that the function perform its job. They don't automatically happen when you run your program. They only happen if later in your program you say, hey, you know that function I made called game over? Do that, please. So all these instructions we're about to enter, if they are indented, only happen when we call upon them to happen by calling on the game over function. With all that said, let's put the instructions in. What do we want to have happen? Well, we already kind of know the logic here. We're going to take the information we've been given. We've been given an argument called number of turns. We just want to know, is that number greater than 10 or not? That's all we care about. So let's write a control instruction. Let's do an if, and in parentheses, we'll put, what if the num underscore turns is greater than 10? We've seen that pattern before, haven't we? Go to the end, hit a colon. Now, if you've been following along, this next part should probably come relatively smoothly to you. But when you're first learning Python, it can honestly be a bit confusing. It confused me when I first learned Python. We're going to hit enter again. And remember, because we just ended this line with a colon, that means the instructions under it that are further indented are treated differently. So hit enter. Notice our code editor, nice and friendly, further indents 2 more spaces. And that means this instruction we're about to write is only going to happen if number of turns is greater than 10. What do we want to do? Well, we're going to print you lose. I'm getting a little more mean. That's what I'm going to do. You lose. Let's just pretend I'm being mean. I'm not really a mean person. So that's what we're going to do when the function called game over gets used. And when we give it some information, if that information is greater than 10, then we're going to print you lose. All right, fine. What are we going to do otherwise? Well, go to the end and hit enter. This part's critical. You don't want to keep writing here. We're done saying what to do if the number of turns is greater than 10. Go back. Only hit backspace once. Only go to the same level as the if. Look at the if right above it. You want the cursor at the exact same spot. And now we're going to define what to do if the number of turns isn't greater than 10. So we use that same instruction, else. Hit a colon. And there's that colon. That means anything indented under here is going to be treated differently. So hit enter. The code editor automatically indents. And we're going to print want to keep Oh, no, we're going to say, you can keep playing. There we go. Now go to the very end, hit enter, and then backspace a couple times because we're done creating this function. Now, I'm going to give a second for people to catch up. Now, I'm going to go up here. We're going to make a change, and I'm going to ask you, please don't run the code. I just want to ask a question once we've made the change. Go up here, go to turns, and make it equal to 20. So here's my question. When we run this code, what's the last thing that's going to be printed over on the right-hand side? Put it in chat. When we run this code, what's it going to say at the very end of all the stuff it writes? What's the last line going to say? Nope, Mark. That's not right. Nick, that's exactly right. Mike, that's right. Good job. So the correct answer, go ahead and run it, is game over, play again. Now, some of you may have wondered, well, why, Eric? We just changed things up here. We said if the number of turns is greater than 10, we're going to print you lose. Why are we printing game over, play again? So let's think like a computer. The computer starts at the very top instruction and performs it. First, it prints hello world. You can see that on the right-hand side. Then it makes a variable called turns. Then it uses that variable by printing, you've taken this many turns. Then it changes the value of the variable turns to 20. Good. Then it uses that in a print statement. Okay, good. Then it has an if instruction, and it says, hey, is turns greater than 10? Which it is. Look, we changed it to 20 right here. So turns is greater than 10, so then it prints these two things. All right. But now some of you are thinking, all right, fine. But down here, don't we now check if number of turns is greater than 10? Absolutely we do. There's two problems here. The first one is these instructions that are inside the definition of this function, they're never going to be performed until we actually ask for the game over function to be performed. We never did. And this is the critical point. This is one of the most important things in all of learning to program. When you're making a function, okay, call it a function or a subprogram or a subroutine or whatever you want to call it, a method, different programming languages use different terms, but it's always this way. When you're creating one, all you're doing is you're creating potential behavior. You're saying, listen, computer, I'm about to give you a bunch of instructions. We're going to give that set of instructions a name. But that's all I'm giving you. You are not to perform these instructions until I ask you to later. When you make a function, you're defining future potential behavior. And we have not asked the instruction to perform. We have not asked the function to perform. That's why it behaved the way it did. So how do you actually ask the function to be performed in Python? It's actually pretty simple. Go to the very bottom, hit enter again, just for readability. The blank line doesn't do anything. And we're going to actually request that this new function we made be performed. You do that just by simply spelling out its name, game underscore over. And then in parentheses, you give it the information you want to give it. What information do we want to give it? Well, I want to know what's going to happen if only one turn has happened. So let's type in 1. Run it. And the final thing that gets printed is you can keep playing. Why? You see that over here. It happens because at the very bottom here, we called this function. That's the term. You call the function. That means, hey, can you do your job? That's what calling a function is. We called on the function game over, and we passed in some information. So the computer goes up to this definition of the function and says, oh, you want me to do this? You gave me some information. You gave me the number 1. Okay. And now listen, this part's important. From now on, says the computer, while I am performing this function, I'm going to take that information you gave me and I'm going to call it num turns. Okay, I'm ready. And it dives in and goes, all right, what's the first instruction? It says, if num turns is greater than 10, well, num turns is equal to 1. I know that because they just gave me that information. So 1 is not greater than 10. All right, I'm not going to do this instruction. What's next? It says else. Oh, well, this is the thing to do because this expression isn't true. So now I know what to do. What do I do? Well, it goes, all right, look at the next line. If it's indented, this is indented, I'll do it. It says print, you can keep playing. And it does that. And then it comes back and says, I did that. I performed the function. That's how the computer works. So we can actually go through a game like this. You can do it over and over again. Let's do a game underscore over. And let's say it's been a little while later and they're at 4 turns. I don't want to put every number in there. Okay. Let's run it. Oh, they can keep playing. Now it's been a little while. And look, call your game underscore over. And now it's been 10 turns. They just took their 10th guess. Well, let's run it. They can keep playing. Now, let's do another game over. $11 turns. Sorry, you lose. Notice is the important part. Each time we wanted to check whether the game was over, all we had to type was 1 instruction instead of 5. That makes it a lot easier. Also, let's say that I wake up in the morning, I'm like, man, Eric, you're being such a jerk. If the game's over, you don't need to be so mean. All I have to do is go into the definition of the function and say, all right, instead of saying you lose, I could say, sorry, game over. And I can do a sad face. Now, every single place that I use the game over function, that change is reflected. So you can change the function and it affects everywhere in your program with 1 change, which is pretty cool. All right. Let me switch over here. Here's what I want to do next. I'm going to take this full code and I'm going to paste it into, let me go to everyone. Grab that link that I dropped into chat. And what I want you to do is what I'm going to do right here. You click somewhere in the document and do a Control A and then a Control C. If you're on a Mac, it's Command A, Command C. In other words, I want you to copy all of the code. Then go back over to your code editor and same thing. Select all the code and erase it. And now Control V, paste in the code I gave you. When you're done with that, just hit play. I'm going to give you all a minute. I want you to play a game of Hangman, and then we'll look at the code. So I'm going to play. Let's see. I'm going to go E. Nope. R. Nope. S. Nope. Oh, I'm in trouble. T. Nope. Ooh. O. I got 1. N. O. Let's see. What if I guessed? I've got ERST, right? Yeah, I've got ERST. And I'm going to go C. Oh, all right. I. Nope. All right. That's enough. I just want you to see what it's like to play the game. Okay. So now let's take a little bit of a look at the code. And by the way, you now have a copy of this code. It's yours to play the game and it's yours to mess around with. For example, it might be interesting to every turn have it list out the letters they've already guessed. Wouldn't that be kind of cool? Okay. But regardless, let me show you a couple of things. Go to the very top of the code. And one is, as you start to look at these words, some of them are going to start to make a little more sense to you now. You see like some comments with the hashtag before them. You see define for defining functions, right? You see making variables. Here's a variable because there's an equal sign afterwards. And oh, it defines, what's the value? Well, it looks like it's all these symbols that we use as someone makes their guesses. Okay, you can start to make some sense out of this code. That's the first thing I want to show you. The second thing is this. There's one instruction here called import. This just means bring in a package, a collection of someone else's Python code that I need. I need some code to generate random numbers. It turns out I can download code that someone else has made to generate random numbers. Please include that in my program. That's all this means. But then what do we do next? Well, we define a function. Please pay close attention to this. Remember that when you define a function, nothing happens until you ask for it to be performed. So I'm going to show you something. If you were to answer the question, what is the entrance point to this program? You'll find a very interesting thing. The first 100 lines of code don't do anything. We make a function here. 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 So far, all we've done is define functions. And now all of a sudden, we call the main function. Just by typing out its name, we call the main function. Oh, finally, we're doing something. And the main function is right here. We make a variable called word. And to give it a value, we call another function. And then we call another function. The whole point, I'm not going to go through the whole logic of this program. That's beyond the scope of what we can do tonight. I just want to point out that the actual entrance point to this program is right here at the very end of the file. Yeah, and you know that now because you can look and go, oh, well, Erik said make a function. It doesn't really do anything until you ask it to, so this isn't going to do anything. We're making another function. This isn't going to do anything. Oh, another function. Another function. Oh, here we're finally calling a function. My God. That's the first actual instruction that gets performed in this program. And that tells you how to start stepping through and figuring out what the program does. You can go, all right, well, let me look at main. Well, it makes a variable and says to get a value, to assign a value, I've got to call this function choose word. Well, let me go find choose word. Let's see, it's a choose word. All right, and what it does, it makes a variable called words. And words is a collection of words. Oh, and then it looks like it's going to return a random word from the list. Hey, that's how we're going to start. And wouldn't that make sense? We're going to randomly choose a word. So you could actually keep this program and you could give it to a friend and you could add in 100 different words here, for example, and make it really challenging. Might keep a 12-year-old busy for a while. It's pretty cool. All right, so after part 22, like line 22 down here. I'm not sure I understand the question. Octavia, can you clarify the question, like where exactly in the code you're running into something? Okay, good. All right, I'll watch for that. All right. Now, let's keep moving forward. I'll watch for that answer. Okay. So I've been watching for questions. I'll watch for that one question from Octavia, but just because we've gone a bit longer here, I'm going to move forward. And I want to give you a bit of data about specifically the boot camps we offer. There's a lot of them. We actually have 12 online boot camps, and they cover a huge variety of subjects, as you can tell. Okay. Artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development, right? In fact, we have more certification programs than any other coding boot camp on earth. But it's how we run them that I want to just stress. I'm only going to give you a tiny sketch here. You can learn a lot more later on. I'll show you how, okay? Oh, line 22 said game over. Okay, on the other code. Octavia, if I have a chance when we're done here, stick around. I'll try to go back to that and explain it to you, okay? All right, so I want to tell you just a couple of things about how these programs are run. It's actually kind of important. They're self-paced. Everybody learns at their own pace. Our programs are designed that way, but they're also instructor supported. They're really flexible. You can set your own schedule, and you can enroll any day of the year. The content on it is really well-rounded on all these programs, really in-depth. They're affordable. As I said, they're priced under the national average. And every program you see here includes job placement training and job placement assistance. But most importantly, these programs are designed for absolute beginners. There's no technology knowledge or experience is required, so you don't have to be a nerd to get through these programs. And who are the programs for? Anyone looking for a better career. Technology is a great industry to work in. There's remote work opportunities. It allows for really good work-life balance, pays really well, okay? We consistently land on every major best coding bootcamp list and have for a decade. And we're really proud of that. Another thing we're really proud of is this. Our average review rating across all the major bootcamp review websites is 4.8 out of 5 stars. And those reviews come from students and graduates telling you exactly what they thought about going through the school. Now, I kind of mentioned this before, but I just want you to consider, why would you want to work in tech? It's not for everybody, I get it. But there are some cool benefits. It has, again, really good work-life balance. You're not finding yourself working 80-hour weeks in tech. I've been in tech for decades. The number of times I've worked more than 40 hours in a week, I remember each of them because they happen so rarely, okay? Also, there's a lot of remote work in technology, which is kind of cool. It's also a really creative industry and one you can take a lot of personal pride in your work in, okay? And it's a stable industry that pays well. And if you apply yourself to it diligently and keep learning, you get regular increases in pay. But the important thing is, it pays better than a lot of industries in America, and you don't have to pay $150,000, $200,000, $300,000 to go to school for it, which is awesome. That said, we know boot camps really well. Okay, there's 3 ways to get into technology. Loretta, that's a great question. She says, have you ever felt burned out from it? I haven't, but I've purposely made it so that I've shifted what my focus is in technology over the years. For a long time, it was pure development and it was contract development. I'd go work somewhere for just 6, 7, 8, 9, 10 months and then get paid really well and then switch to a different company, right? And did that over and over again for many years. And I got a lot of variety from that, right? But I decided I want to settle down a bit. And when I settled down a bit, I was at a company for 4 years, right? But even there, I found a way to shift into a different section of the company and be doing really consultative work with like Fortune 100 companies, doing huge transformation initiatives with them instead of just programming. I also found a way to teach a lot. Either that's my primary job or I did it on the side. Like, I made sure that I was always attacking technology from a different viewpoint. I just love technology, but you're absolutely right to ask that, Loretta. You do the same thing over and over and over and over again. Some people can get burnt out by that. I've specifically made sure I learn a lot of different things and work in a lot of different areas. And no, I've never really felt burnt out from it. Or when I did, I had been delving into another area, and so I could shift easily. So I didn't stay burned out for long. Does that answer help, Loretta? Is that good? I like that question. Excellent. Cool. Okay. So again, we know there's 3 routes to get into technology. Period. There really are only 3 ways to get into the technology industry: college and university, a boot camp, and self-taught. That's it. That's where people get into the industry. Okay. We know boot camps really well. I happen to know the other areas really well too, but let's look at boot camps. There are definitely some barriers to doing a boot camp. Fully acknowledged, right? One of them is money. It costs thousands of dollars to do a boot camp, tuition. Okay. What we've done to try to make that a lot more approachable is we have multiple financing options, including a rather large upfront discount or monthly payment options for people with any variety of credit situations. Okay. I will say that, obviously I'm biased. I'm the co-founder of the school, but we've gotten thousands of people into tech. This is the way I really feel about it. Getting through a Tech Academy bootcamp is genuinely an investment in yourself. So yes, it costs money, but what you come out of it as is a well-rounded entry-level developer, fully capable of being part of a development team, and someone who right out of the gate makes on average $30 an hour, and it goes up from there, and you're in an industry that's not going anywhere. So yeah, it can take some money to get through. We try to make that easier to confront, okay? Another barrier to getting through a boot camp is frankly time. There is a lot to learn. Even though we try to keep it to those fundamental things, the practical modern skills that are needed by employers, there's a fair bit to learn. Some boot camps try to handle that by making you train in what's called a cohort. Everybody starts on the same day and moves through the curriculum at the exact same pace. Personally, I cannot tell you how much I do not like that style of training. It does not work for me, okay? Some boot camps even require that you go into a campus, okay, and learn in person. Our programs are fully online. They're self-paced. You choose your own study schedule. Part-time study schedules allowed, which means you can study concurrently to holding a job or attending some other school, okay? Finally, in terms of a barrier to getting through a boot camp, there is the aspect of personal technical interest and ability. Now, interest, I mean, you guys took a Friday night and attended a free coding class. There's probably some interest there. That's awesome. The one I want to just kind of help you with a little bit, if it's an issue for you, and it may not be, is this. Have you ever felt like when you were studying some sort of computer technology or programming concept, whether it's in a book or an article or an online video or whatever, have you felt like, wow, maybe this isn't for me. Maybe I'm not as smart as you need to be to get through this. If you've ever felt a tiny bit of that, I want to assure you, it's not you, it's the curriculum. It's really common in the technology industry that some education materials are too hard because the person making the curriculum assumed too much prior knowledge on the part of the student. I know this because I've done it, but we don't do it in our programs. At our school, you don't have to be a nerd to get through the program. You have no technical background is needed to enroll and get through and succeed in the program. So with all that said, I've got a question for you. Is it time for a change? Specifically, are you maybe working a dead-end job? Maybe you like the job and that's all fine, well and good. But when you look forward 5 years, 10 years, is it really going to get you where you want to go in terms of lifestyle, economic earnings, that kind of thing? Maybe you're even unemployed, or maybe it's important that you work from home and the kind of job you have, that's just not part of how that industry works. Or maybe you want more time with your loved ones, right? The whole point is it time for a career change? I don't know if it is or not. It's a question for you, but if it is, the Tech Academy is the solution. We are, in fact, career change experts. We designed this bridge here in our logo for a very specific reason. We tried to design a route into technology for everyone. I firmly believe that any reasonably bright, intelligent person who wants to get a career in technology should have an avenue into technology. And it works. We have over a decade of experience getting people into tech. Most of our graduates, as I said, make $30 an hour in their first job. That's the historical average, and it's thousands of graduates. It's not just like there's 5 people that did that, okay? And they work in a lot of different places, everywhere from small, mom and pop businesses, small to medium-sized businesses, to huge companies like Facebook or Epic Games or Disney or Uber or Nike. We've gotten people hired at all those places and everything in between, okay? So as a reminder, we have open enrollment, which means you can start anytime. And I highly encourage you to enroll now. Now, we do have some special things we're doing in October, which is for students who enroll this month, there's a 50% tuition discount if you can pay up front. That's the biggest we've done in the past, okay? Also, if you pay up front and you need a laptop to do your training, we'll send you a refurbished laptop if you're in the US. We don't send them out overseas, okay? Also, if you enroll in October, you don't have to pay any sales tax. We'll pay it for you, no matter where you are, okay? Also, we'll send you physical copies of our coding books and our technology dictionary that you can use while you're studying. It helps a lot to have that physical book there and go through it, okay? Also, and look, this is just 3 little words, but I have to tell you personally, as someone who's worked in and around technology for decades, this is a book you want. This career planning guide lays out exactly how to navigate your first 6 months after you've broken into tech, your first 18 months, and your first 36 months. What do you do and in what order so you can stably set yourself up for a really good long-term career? This is information that took us a long time to learn. Lots of hard-won knowledge. We put it all in a book and you get a free copy of that, okay? Also, if you sign up in October, you get 3 months of free access to what's called the Tech Academy Accelerator. I love this service. This is it's a monthly subscription service that gives you access to over 100 educational videos and courses, but it also gives you access to our weekly accelerator workshops. These are phenomenal. They're specifically designed to take people who are in tech and advance their career, they accelerate their career, right? And these workshops are deep dives. They are open video, open mic, back and forth communication with me. And we really get our hands dirty and dive into some really cool stuff. Also, we teach what the community members ask for. It isn't just, hey, here's what we're going to teach, take it or leave it. I'm the one that runs them, and I get input from the students or the community members all the time, and I teach what you need. And I just love doing them, okay? And finally, if you enroll in October, you get unlimited job placement assistance from our job placement personnel. As long as it takes, we will work with you till you get hired. So, again, stick around for your free gift. It's coming, okay? If you want to know more, if you're even remotely interested, grab the link that Jessica's going to drop into chat and fill out the form there. It's a simple form. Immediately after the form is a series of steps that tell you all about the school. We lay out what's the exact series of courses, what's on them, why are they in that order, how are they taught, how do I interact with instructors, what happens when I submit my coding examples, how do I do a live project so I really get practical experience coding. All of those are answered when you follow those steps right after the form, okay? You can even book a call with admissions from there. It just gives you everything you need to know to make a decision about our school. I'm not saying we're for everybody, but if there's a chance we're for you, check it out, okay? I'm gonna give people a second while I take a sip of water to grab that link. I went a little over tonight. Thank you for sticking with me. I super appreciate it. All right, I want to talk about a referral program. Since our graduates are, really love us, referrals have been a consistent part of our enrollment sources for years. And so years ago, we put in place a commission payment for referrals, right? And it's simple. If someone that you refer ends up enrolling, we give you 5% of their tuition. And that's not just for our students and graduates, that's for you as well. In a moment, you're going to be given an email address where you can get a hold of us to get your free gift, and you can include referral information in there. We do keep track of it, and we do pay those checks. We enjoy paying them. I've talked about books. We have 7 publications, including 3 Learn Coding Basics books, a coding book for kids and young adults. If you have a young adult in your life, this is a phenomenal gift for them. We have a Technology Basics Dictionary I talked about, Project Management Handbook, and You Are Not Stupid, Computers and Technology Simplified. Everybody should read that book. But now we come to our free gift, and it is our Intro to Python book, an actual physical copy. For students, for people in the United States only, we will send you a physical copy of this. And all you got to do is email us with your full name and mailing address. There's the email address Jessica just dropped into the chat. Okay. Grab that, send us an email, say I was on the class with Erik. He said I could get a free Intro to Python book. Here's my mailing address. Go ahead and send it. And we love sending. There are people at our company who like their sole job, what they're tracked on every week is how many of these free books did we send out? We want to have these in your hands. So please ask for one. They're really good. Okay. Also, you can include any more questions you have for us or any referrals in there. So I'll give you a second to grab that email address. Now, I mentioned that these are recorded and they go up on YouTube. The way to get that is to use our link tree. Jessica's going to drop a link to our link tree in there. It's just a site where it aggregates all of our links together. You'll find links to our free educational YouTube video playlist, links to our books, our dictionary, to our upcoming meetups, to our social media accounts. So please follow us on social media, come to the next class, right? And again, if you have even any slightest idea that maybe the programs we have are for you, fill out the form, find out more. It's worth it. So I want to thank you again. You took a Friday night when you can be doing anything and you spent it with us, learned a bit about programming. I hope you appreciated or got a feel for how we like to break down technology and teach things in the right sequence. And we'd love to have you be part of our community and our school. So thank you all so much for attending.